All right, chapter 5 is a fun chapter for me. It's scary. It is calculating heart rate. What's scary about it? Just that very first word, calculating. So we will be doing some math. It's not too difficult. If you follow the rules, you will do just fine. Do not let that word calculating or math scare you. So now that you know what the parts of the heart are, what the function of the heart are, and what the conduction system is like. And you also know, well, how do we get the views of the heart, your lead placement, and also what your normal EKG rhythm should look like and what artifacts we might have. So now we're going to talk about, now that we know all of the basics of what that EKG rhythm should look like, what we're doing when we're doing an EKG, and what the job of the heart is and what it looks like on an EKG. Now we get to really figure out, well, where do we go from there? How do we know somebody is in danger, is having a heart attack? How do we know somebody's rhythm is not normal? And there are different rhythms out there, and once we get that different rhythm, what part of the heart is different on that rhythm? Is it the atrium that are failing? Is it the ventricles that are failing? So the first step that we're going to do is we're going to calculate our heart rate and see what should the heart rate be and what that will indicate if we are not within the normal heart rate range. So this slide is super important. A lot of students, when we get to EKG 2, I will hear students say that they never learn the difference between your atrial rate and your ventricular rate. And this is the slide that I will tell you to come back and find and say, yes, we did discuss it. And what's great about these recordings is you can watch them as many times as you need. Whereas if we were in that classroom setting, you would only have it that one time. And here you get to just repeat as much as you need until you understand what's going on. So your heart rate is the number of QRS complexes per minute. So how do we calculate your heart rate? We're going to count the number of QRS complexes per minute. When we do this count, we're counting those complexes. We're going to get what's called your ventricular rate. What is ventricular? Ventricles. What is the rate of my ventricles? What is the conduction rate of my ventricles? How long does it take for that conduction to go through? Your atrial rate, hence the word atria, that's your atrium. How do we calculate that atrial rate? We're going to count the number of P waves per minute. So if I want the atrial rate, what am I going to count? P waves. If I want ventricular rate, what am I going to count? QRSs. When we calculate heart rate, we are then going to count the QRSs. Rerun, right, go back right for a second. Ventricular rate, what do I count? QRSs. Atrial rate, what do I count? P waves. But if I want to know the heart rate, what am I going to count? QRS complexes. So we have three methods that we can use to calculate this heart rate, and it's not really a preference on the method that you choose to use. It's more of the rhythm that's going to tell us what method to use. So for my 6-second strip method, now remember we just said QRSs is going to be counted for 1 minute. Atrial, your P waves are going to be counted for 1 minute. Heart rate counted for 1 minute is your QRS complexes, your ventricular rate. For the 6-second strip method, this is the least accurate of all methods, meaning it's going to give us an estimate what that heart rate is, but it's not precise, it's not accurate, and it can be off. Therefore, it is the least of the three methods. It is the least accurate, and it can be misleading. You're going to count the number of QRSs on a 6-second strip and multiply by 10. So for example, if I have 5 QRSs, 5 times 10 is 50. That patient's heart rate is 50 beats per minute, BPM. This is going to give me the mean heart rate. Oh gosh, we're back into math, right? Mean, median, and mode. What is mean? That is the average. So if I count the QRSs for 1 minute on a 6-second strip, that is going to tell me my ventricular rate, which is also my heart rate. If I have 5 QRSs, 5 times 10 is 50. That is the average, the mean rate of that rhythm on 1 minute, 6-second strip. The 6-second strip method, this is going to be treatment. So this, you're going to find out the more we go, you're going to be learning the different types of treatments that there are. If you start memorizing this now, it will help you when we get to EKG 2. So the 6-second strip method, treatment for a rhythm disturbance, depends in large part on the heart rate. Again, how do we get the heart rate? We're going to count the QRSs on a 1 minute, 6-second strip. We're going to multiply them by 10 and get the heart rate. If it is a normal heart rate, do I need to treat the patient? No. But if my heart rate is outside of the normal rate, I am going to have to treat that patient. So it's depending on the rhythm, the disturbance that depends on the heart rate. So it makes more sense to provide a range of heart rates. There's another math word right there, of heart rates, from the slowest to fastest. Write this down. When we figure out the range, it is the rate from the slowest rate to the fastest rate. A lot of times students forget this. If you remember in a previous lecture, I said to get you a note card and to write down the rules, your intervals. On that note card, you need to write down these 3 methods, and you need to write down your range, which is the slowest to fastest heart rate. So for example, we have rhythm A and rhythm B. Here, if it's telling me these 2 rhythms both have a mean rate of 50, but they look different, right? So how do they have the same mean rate? To figure out the mean, which is your average heart rate, we're going to count how many QRSs we have. 1, 2, 3, 4, 5. And we're going to multiply them by 10. 5 times 10 is 50. Or you can count like so. 10, 20, 30, 40, 50. So both of these rhythms have the same mean heart rate. This is known as your 6-second method. Alright, moving on. Your second method. This is called your memory method. This is the most widely used method in hospitals. It is the fastest method, and it is 300 big blocks every minute. Now, remember, we discussed how many seconds is one little box, which is 0.04. And then how many seconds was 5 of these little boxes, which was 0.20. This is also something really good to put on your note card. And then 5 big boxes of these 5 little boxes gives me 1 minute. Okay? So remember that. So to get my memory method, I am now going to count using my 300 big blocks for every minute. So you're going to count the number of big blocks in between consecutive. What does consecutive mean? 2 in a row. QRS complexes. And then we're going to divide into 300. Why is it called memory? Because the memory, if you memorize 300, 50, 100, 75, 60, 50, 43, 37, 33, and 30, that if you memorize the sequence of numbers, then you do not have to calculate by 300 because you've already remembered it. This is a little too much for me, so I always go back to dividing by 300. This is given in a different way. It's giving you a chart, and it just shows you on your first column that the number of big blocks between the QRSs. So if we have 1 big block in between 2 consecutive QRSs, then that heart rate is going to be 300. 2 big blocks, my heart rate is going to be 150, 3, 100, 4, 75, and so on. In your little block method, we're going to count the number of little blocks between your QRS complexes, and we're going to instead divide them by 1500. So on your memory block method, we counted the big blocks in between those consecutive QRSs, and we divided by 300, or you can memorize your sequence. But for the little block, we're going to count the little blocks between those QRS complexes, and we're going to divide them into 1500, as there were 1500 little blocks in 1 minute. Use this method to calculate the heart rate range and irregular rhythm. So notice range came back. So when we talk about the 6-second method, we're counting the QRSs and we're multiplying them by 10. When we talk about the memory method, we're counting the big blocks in between our QRSs and we're going to divide them by 300. And if we're doing the little block method, we're going to count the little boxes and divide them by 1500 in between those 2 QRSs. But the mean is going to be my average heart rate. It's not going to be the most accurate. It is just an average heart rate, and it is the least accurate. For my memory method, this is the most widely used method because it's the fastest. And for my little block method, we're going to use this one only if we have an irregular rhythm. But if we're using this method and we have an irregular rhythm, we have to find that range. And range is going to be from the slowest rate to your fastest rate. And remember, we have your atrial rate, which is counting your P waves. We have your ventricular rate, which is counting your QRSs, and your ventricular rate is also going to give us your heart rate. And to get your heart rate, we're going to use these 3 methods, which is the 6-second, the memory, and the little block method. To calculate the heart rate, that's the slowest, we're going to find 2 consecutive QRSs that are closest together. And to calculate the heart rate that is faster. So to find 2 consecutive QRSs complexes that are the closest together, and then you're going to calculate the fastest. I'm sorry, I said that completely wrong. Let me just read it. Use this method to calculate the heart rate range and irregular rhythms. Find 2 consecutive QRSs that are the furthest apart. That's going to give you your slowest rate. And the 2 consecutive complexes that are the closest together is going to give you faster rate. So your range is going to go from that slowest to fastest rate. So here's an example. In this figure, they want you to do the little block method of calculating a heart rate. Again, So what is the little block method? That is going to be for an irregular rhythm. If you look at this rhythm, we know for our rhythms we need to have P, Q, R, S, and T's. But we also need to have a bass line in between each heartbeat. So you know that each one of these spikes is your QRS's and is a heartbeat, each one of these. Okay? So we need to have a bass line in between each one of those beats. And if you're looking, you really cannot see a bass line. So does this look like our normal rhythm, which has a bass line, a P, a PR segment, a QRS, an ST segment, a T wave, then we have the bass line, and then the next beat? Does this look like a normal rhythm that we've talked about so far? No, and the first thing I notice is my bass line, okay? So this, therefore, is an irregular rhythm. And if I have an irregular rhythm, what method do I use? Do I use my 6 second? Do I use my memory? Or do I use my little block method? Well, I know that my 6 second is least accurate. So if I have an irregular rhythm, wouldn't I want the most accurate rhythm? Heart rate? Yes, because I want to see what's going on with this patient. My memory method, that is just a faster method, and my little block is going to give me the most precise. So the majority of the rhythms that we're going to be looking at are going to be irregular rhythms, and you're going to be doing the little block method the majority of the time. But you could have that regular rhythm and just get the mean rate, which is your 6 second rate, or use your memory method, which is the fastest way to get your heart rate. You might want to use that memory method in emergency and also on your national certification because you're at times and don't have time to calculate this. In class, I let you use calculators, but for your certification calculations, calculators are not allowed for calculation, so you have to do it all by hand. So if you want to just go ahead and start making a habit now by calculating by hand, that's probably the best thing you can do for yourself, so you're not relying on the calculator. Or memorize that memory method. So regularity. This is based heart rate calculation. The heart rate calculation is regularity based, meaning that the rhythm regularity is concerned with the spacing of QRSs. So I just mentioned, I noticed that there was no baseline in between my consecutive heartbeats, which means this rhythm that we just looked at on the previous slide was irregular. If I had that spacing, that flat line, the baseline in between each beat that was not too long or not too short, then I would have what's called a regular rhythm. And this is trying to figure out the regularity. So your regularity can be regular, or it can be irregular. And in a few slides ahead, it can also be interrupted. So you're going to compare what's called your R to R intervals. Now remember, we talked about your PR interval, your ST interval. We also talked about measuring your QRS complex, and we talked about your R to R intervals. So we're going to compare these intervals to determine our regularity. We're going to count the number of little blocks between the QRS complexes from spike to spike. A regular rhythm, the regular R to R intervals vary only from 1 to 2 little boxes. So you'll notice when you start doing these calculations and you start calculating these rhythms, some of the boxes aren't going to be exactly the same amount in between. As long as they're close by only 1 or 2 little blocks, and then it's going to be considered regular. QRS complexes, they usually are going to look alike. So notice, this is still considered my QRS complex, But to be more specific, if I were to label the Q, the R, and the S, this would be what's called your QS complex. So even though it is a QS complex, we're still going to do an R to R interval. That R to R interval is the measurement of little boxes in between two consecutive QRSs. So here is a QRS, and the consecutive QRS is right here. And I am going to count little boxes. So I'm going to count from this spike right here to this spike right here. And again, I'm counting the little boxes, and I'm trying to determine, is my rhythm regular or not, the regularity of my rhythm. I know that each one of these big boxes has 5 little boxes inside them. And I already learned that if I count those boxes to the right, I'm going to get time. And if I count those boxes going up, I am going to get amplitude. Okay? Amplitude is your conduction system, right? Okay, so how fast is that signal amplitude going through that heart tissue, your ventricles or your atrium? How soon? What is the time? So I'm going to go ahead and count in between these first two QRS complexes and get my R to R interval. I should count all these little boxes and get 23. I'm going to write that number down in between, and then I'm going to go to my next two QRSs, which is this one and this one. Count the little boxes in between, and you should get 23, and so on. So you're going to count these two. How many little boxes? This is going to tell me whether I'm regular or irregular. Notice the little boxes in between each of these R to R intervals, we got 23, 23, 23, 23, 23 and a half, 23 and a half, and 24. Would you say that these are 1 and 2 boxes off? Yes. Would you say this is regular? Yes, because we are going to have 1 to 2 little boxes off. Now, let's say I got 40 boxes over here, and I got 15 boxes over here. My R to R interval over here, is it 2 boxes less than over here? No, it's a lot of boxes left. Therefore, it is not a regular rhythm. So regularity-based heart rate calculation. Regular but interrupted. The regular rhythm can be interrupted by a premature beat or a pause. Close inspection reveals that only 1 or 2 beats or a burst of several beats make them look irregular. Your R to R intervals are regular until a beat pops up prematurely. So in other words, if I have a regular rhythm, and then in one section of that rhythm I have something that's not regular, and then it goes back to a regular rhythm, then I would have what's called your interruption. And your interruption can be interrupted by a premature beat or a pause. Okay, so remember your R to R interval, if we're trying to determine regularity, we're going to look at the little boxes in between your R to R interval. Your first R to R interval, how do you find the R? That's your QRS complexes. If you're unsure because your T wave here is really high, it is always going to be that spike. So your first 2 consecutive R to Rs, they counted 15 little boxes in between. Your second 2 R to Rs, they got 15 and a half. Your third one, 15 and a half. Your fourth one, 15. But your fifth one, we got 11. Is that more than 1 or 2 boxes off? Yes. Then we jumped up to 17, to 16, 15, 15, 15. So you'll notice in this section over here, right over here, we are regular. And then in this section over here, we're only 1 and 2 boxes off. So I'm going to say over here we are regular. But right here, are we 1 to 2 boxes off from 15, 16, and 17? No, which makes us interrupted. And in this case, we are interrupted by a premature beat. A pause is going to be a flat line. So that's how we know that this is a premature beat. I want you to also notice if I were irregular and I needed to get the range, I can do this by looking at, remember, the closer, in this case is on the 11, the closest those are complexes, the faster the rate, and the further away, which is my 17 right here, the further away, the slower the beat. So my range needs to go from the slowest to the fastest rate. So my range here would be 11 to 17. And that is just if I were looking at the little blocks. But remember, we need to divide those depending on the method we are using. And if we're getting the range, it is probably an irregular rhythm, so we would be doing the little block. So we would divide 1500 by 11 and then 1500 by 17, and that would give me the slowest to fastest range for heart rate. Regularity-based heart rate calculation, the regular but interrupted by a pause. So your RR intervals are regular until there is a pause. These pauses are like a sudden power outage. Meaning, let's say you have to go flip the breaker. Power goes out, flip the breaker, comes back on. So you only have a pause with no power going on. So remember, your R to R interval is the little boxes in between these spikes, and they have to be between the 2 consecutive QRSs. So I would measure between these 2 and get 25 little blocks. And then I would count between these 2 and also get 25. And then my next consecutive QRS is way over here. And I got 43, which means there is no premature beat because they would be closer together. And since this is further away, this is known as your pause. And you can see it. There is your pause. So, irregular rhythms. My R to R intervals are going to vary throughout the strip with no pattern. So, regular rhythms, we're going to get 23, 23, 23, 23, all the way across from my R to R intervals. But if I'm interrupted, I might get 23, 23, 40, 23, 23, 23. I'm interrupted by a pause, but I'm still considered regular just with an interruption. Or I could be interrupted by that premature beat. I could be 23, 23, 23, and then go down to 11 and then go back to 23, 23, 23, 23. I have that premature beat. If I am irregular, ain't nothing going to be regular. I could have an R to R interval that's 23. I can go down to 11. I could go down to 40. Then I'm up to 40. Then I can go back to 30. Come all the way back down to 11. There's nothing regular about your R to R intervals, which means you are an irregular rhythm. So your R to R intervals are going to vary throughout the strip with no pattern. The rhythm is intrinsically chaotic. The pattern is one of unpredictability. And whenever you see a rhythm that looks irregular, look closely to make sure that is not a regular but interrupted rhythm. So, again, you're going to count little boxes in between my R to R interval, and you should get 17 here. You should get 20 here, which is it's 3 boxes, so that's kind of hard to say. But then we jump, when I do my measurement over here, to 30, all the way back down to 11, to 21 to 13 to 18. Are any of these numbers within a 1 and 2 boxes away from each other? No, it's intrinsically chaotic. It is an irregular rhythm. And again, I determine that by my R to R interval measurement. How do I get my R to R interval? I count the little boxes between two consecutive R to R's. So I believe the rest of your PowerPoint is practice problems. So I'll do the first few with you, and then you need to do the rest on your own. It's really easy to listen to me and understand and watch the PowerPoints and know what I'm saying. But when it comes time to do it on your own without watching me, that's where students tend to struggle. So if we were in a normal class setting, I would finish your lecture now, and then I would have you do the practice problems in class, and I would walk around and assist anybody who needed the help. Also, if this is where having your book is going to come handy, and if you don't have your book, just go ahead and print your PowerPoints and try to do your best doing it that way, or do it online and take your own notes. Whatever is easier for you to be able to do these practice problems, but you need to be able to do them on your own without me telling you how to do it. You need to memorize your rules. Your rules are the 3 methods that you use to calculate heart rate, and it's also your rules of regularity and irregularity, irregular rhythms. So I can't say this enough. The more you practice, the better you get at it, the more it sticks. So definitely, please do not just skip over this chapter and think because you understood the lecture that you can do it. You need to prove to yourself that you know what you're doing. Get in your book and do these practice problems. Practice 1. So right now, the only thing we're trying to determine is the regularity of a rhythm. How do you figure out the regularity of a rhythm? You are going to count your little boxes in between your R to R interval. Where is your R? Your R is the spike, and the interval is the time in between 2 consecutive spikes. That's consecutive spikes. If I am only a box to 2 boxes off for the whole strip between my R to R intervals, I'm a regular rhythm. If I am only 1 section off, it could be a pause, interrupted by a pause, or a premature beat. But if I have all kinds of crazy numbers, I am irregular. So let's do the first one together. So where are your first 2 QRSs? Here's the first one, and here is the second one. So this is what I'm looking at to measure. I am looking here and here. So notice that right here, my spike is about half a box before this dark line right here. Okay, so I'm going to use that to count. So in the classroom, I would show you to take a pencil and to just draw along on that QRS and go from there. So I know I'm a half a box here, and I know I'm a half a box here. This big box has 5 little boxes going across. This big box has 5 little boxes going across. And then this big box has 1, 2, 3 little boxes. But remember, we have this half right here, 0.5. And this box over here has 0.5. So if I were to add that 0.5 to 3.5, that will give me a total of 4 boxes. So I would have 14 boxes in between here. And I'm gonna clear it so that we can double check. 5, 10. And I'm just counting those two big boxes that I can clearly see. So 5, 10, 11, 12, 13 and a half plus this half over here equals 14. So I counted 14 boxes in between these two R to R intervals. Now I need to count the boxes to my next interval. I'm going to count the big ones. 5, 10. I'm going to count that as a whole box because it's right on the line. 15. And I'm going to count this box over here and get 16 little boxes in between. Now I'm going to go to my next one. I can clearly see two big boxes plus maybe a half a box here. So that's 5, 10 and a half. So here I got 10.5. Okay, next one. I can clearly see 4.5 boxes here. 4.5. Here goes 5 boxes here and 6, 7, 8 there. So I got 8. So let's say 9.5 if I was to continue counting, because that's 4, 9.5, 10, 11. I got 12.5 point here. And I know this is hard. It's hard recording and trying to draw in here versus doing it in person. So if you just try to follow along the best you can. I'm going to do it one more time so you can see how I'm getting these calculations. I need to find my R to R interval. How do I find that interval? I am going to count the little boxes in between two consecutive spikes. So if I were to count this spike in between this spike, I'm going to count the little boxes in between. I know that these big boxes are worth 5, so I'm going to count the ones I can see. 5, 10, and then I'm going to count the little boxes adding on to those big ones. 11, 12, 13. That looks like half a box and a half a box. 14. Then that's going to be the first. Then the second two QRSs. Count the little boxes in between. 5, 10, 15, and plus that one box in the front is 16. Then the ones in between the third and fourth QRS is 10 little boxes. And then between the fifth and sixth QRS, 12.5. And then in between these right here, I see one whole box, which is 5, plus 2 little box, 6, 7, 8, 9. I got 9. So I don't need to keep on counting to see that 14, 16, 10 and a half, 12 and a half, and 9 are 1 or 2 boxes away from one another because they're clearly more than that. Therefore, this would be an irregular rhythm. Oh, look at this one. Okay. So this would be a slower heart rate. Why is it slower? Because look how far away my R to R intervals are. They're pretty far, right? So I need to count these little boxes in between these first two consecutive QRSs. So I'm going to go 5 here, 10, 15, 20, 25, 30, 35, 40, 45, 50. I'm going to say 54 boxes here. I can clearly see, plus my one box over here. I got 55. Same thing. Count the QRSs, the little boxes between your QRSs here. And I'm going to count backwards just because this one falls on that dark line. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. I got 56. Now, even though this is a lower number and a slower heart rate or a slower beat, my R-to-R intervals are only one box away from each other. Therefore, it is a regular rhythm. Okay? Now, see, this is when we cannot use our eyesight and estimate, is this regular or irregular? You have to calculate your R-to-R interval. Here, I can clearly see 1, 2, 3 big boxes. Here, I can see 1, 2. I'm going to count that as 3 by combining the ones on the end. 1, 2, 3. 1, 2, 3. 5, 6, 7, 8, 9. Yep, 3. No, I'm sorry. That's only 2. Right here. 3 here. 1, 2, 3. 1, 2, 3. All right. This is going to be a regular, but interrupted by a premature beat. Okay, and again, I counted little boxes in between consecutive QRSs, and those little boxes stayed within 1 and 2 boxes apart until I got here. It was fewer, and then I went back to being only 1 to 2 boxes apart, which means I was regular, was interrupted, and then went back to being regular. This one you can see is also going to be could be an interruption right here with a pause. So this spike lands right on that solid line, and this one is midway between 3 boxes. So if I count each one of these big boxes, which contains 5 little boxes, I can count by 5s. 5, 10, 15, 20, 25, 26, 27, 28 little boxes. Then the next ones we're going to have, I have 2 boxes here, and I have 1 box here. So I'm going to count and then add my 3 little boxes at the end. 5, 10, 15, 20, 25, 26, 27, 28. All right. I have 4 boxes here and 1 box there. 4 plus 1 equals 1 whole box. So I'm going to count that as 1 box. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Is 28 1 and 2 boxes away from 60? Nope. Let's see what we have over here. I have 4 boxes here, and then 5, 10, 15, 20, 25, 24. I went down to 24 here. So even though I have, my 24 is not that close to my 28, this could still be a regular rhythm with a pause because I'm just 2 additional boxes away. I'm 4 additional boxes away from the 28, but I went back to, I was in a closer range, but my 60 is clearly not within range, therefore it is a pause. So this is regular rhythm with a pause. Okay, here's the one. Actually, I'm going to let y'all do this one on your own. So practice this at home. If you need help, feel free to send me an email or call and leave me a voicemail, and I can return it and reply back to you. All right. So now that you figured out or now that you have a better understanding of regularity and how we determine that regularity, or if it's irregular, now we can decide, if I'm a regular rhythm, what method am I going to use? If I am irregular, what method am I going to use? Which you already know, if you're irregular, you're going to use the little block method, and that's going to be divided by the 1500. And then your memory method is going to be the fastest method, which is divided by 300. And then your the least accurate is your 6-second, which is usually just used for your regular rhythms. So for regular rhythms, we're going to choose any 2 consecutive QRS complexes, and then we're going to use the little block or the memory method. But for irregular rhythms, we can use the 6-second strip, and we're going to calculate the heart range using the little block method. So this is a very important slide to write down, to remember. It's going to come back at the end, at the beginning of EKG2 and at the end with your national certification. So how do I choose what method to use based on their regularity? For regular rhythms, we're going to use the little block or the memory method. For irregular rhythms, we're going to use the mean rate, which we get by the 6-second, and then we're going to get the range, which we can get from the little block or from the memory method. For rhythms that are regular but interrupted by a premature beat, guess what? We're going to ignore that premature beat. Pretend like it's not even there, and we're going to use the little block or memory method. For rhythms that have that are interrupted by a pause, we cannot ignore that pause, and we're going to get the range, which is the slowest rate to the fastest rate. So remember, for heart rate, we have what's called your ventricular rate and your atrial rate. If I wanted to know my atrial rate, I would count the P waves, the distance between my P waves. If I wanted to know my ventricular rate, I'm going to count the distance between my QRSs. How do I count the distance between these complexes? I'm going to count the little blocks, which I know one little block is 0.04 seconds. And that's going to tell me how far in between and my heart rate as well when I do my calculations. So for rhythms regular but interrupted, we're going to ignore it. For rhythms with a pause, we cannot ignore it, and we're going to get that mean rate as well as our range, which is the slowest to the fastest rate. So here's a regular rhythm with an interruption of a premature beat. We can clearly see 3 big boxes here, 3 here, 3 here. We're going to ignore this one right here, 3, 3, 3. Well, why are we ignoring this? Well, maybe this is somebody who sneezed. It's just something that, just for that split second, right? It's a 6-second strip. Maybe they sneezed, maybe they held their breath. Who knows what they did? But if we're regular before and after it, then we are just going to ignore it when we do our heart rate. And then here is a pause. Can we ignore a pause? No, because we need to know how long your heart, the conduction system, was not flowing or conducting. So then we're going to count. We get 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3 and a half right here. But for my pause, I have 1, 2, 3, 4, 5, 6, 7. So I would have to get my mean rate here, and then I would have to get the range. So how would I get the mean rate? So we already know that this is regular but interrupted. The mean rate we're going to get by doing the 6-second method, which remember is counting by 10. 10, 20, 30, 40, 50, 60, 70. So my mean rate is going to be 70 beats per minute. Now I need to get my range. which is going to be slow to fast. Over here, if you remember, I got 3.5 boxes, and then all of these other R to R intervals, I got 4. So my mean rate is going to be 3.5 times 0.04 seconds, and 4, which I know 4 times 4 is 16, and 3 times 4 is 12, so my slowest rate is going to be 16 to 12. So notice that my bigger number is going to be the slower, and the smaller number is going to be the faster rate. And this again is a regular rhythm interrupted by a pause. So here's a little chart to help you remember. Regular rhythm is going to be 1 heart rate. Irregular rhythm, we need to get the range, slowest to fastest, plus the mean. The regular but interrupted, we just need that 1 heart rate. And regular with a pause, we need the range. So if it's regular but interrupted with a premature beat, we just need your basic heart rate, which you can use the little block or the memory method. And if it's irregular or interrupted by a pause, we then need to we can use the 6 second for irregular, but we still need to get the range. All right, that's it. Last 10 slides are rhythms, I believe. Do those on your own. And I'll do 2 of them with you real quick. So again, we're going to look at, we got to determine, am I regular, irregular? How do I determine that? I need to count the little boxes in between. If you fully understand that 1 big box equals 5 little boxes, you can count by 5s and then just add in the little boxes that are on the outside. So I'm going to count in between my R to R's right here. Right here, I can clearly see 2 boxes here, and I'm not going to count this one over here. So 5, 10, 15, 20, 25, I got 27 here. Then when I go and count the next one, that looks like 3.5 boxes. So 5, 10, 15, 16, 17, 18, I'm going to say 19, 20, 21, 20. I got 23 boxes here. My next R to R interval, I'm counting the little boxes in between. I get 5, 10, 15, 20, 25, 26, 27. I'm going to say I'm going to just say 28 because it's very hard to tell. So I'm going to get 28. The next one we see 5, 10, 15, 16, 17, 18. 5, 10, 15, 16, 17, 18, 19, 20. 5, 10, 15, 21, 22. I'm going to say 22. So based off of my R to R intervals, is this a regular or irregular rhythm? It is an irregular rhythm. And what is the rules for irregular rhythms? We can do the 6 second, but we still need to get that range. So the mean rate here, which is my 6 second method, is 10, 20, 30, 40, 50, 60, 70 beats per minute. And then we need to get my range, which is going to be my slow to fastest rate. So I've already done the work. Now I just need to calculate. My smallest number is 18. My biggest number is 28. So let's see. If I want to figure the rate for my my ventricular rate, I'm going to my calculator because I can't do it right now while I'm recording. And if I counted those little boxes in between, which is what I did, I'm then going to divide by 1,500. So 1,500 divided by 18 gives me 83. And then 1,500 divided by 28 gives me 53. So my slowest rate was 53 beats per minute, and my fastest rate was 83. And let me double check that 18 divided by 83. And that is my range, and I am looking at my ventricular rate. Okay. Oh, this one's a little bit harder. So it's kind of hard to tell where your spikes are, but you can still make them out. Here's a spike. There's a spike. Here's a spike and a spike. 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 Okay. Then we're going to count in between. I see 5, 6, 7, 8, 9, 10, 11. I got 12 here in between my QRSs. 10, nope, that's 9. I got 11 here. I got 11 here. 5, 6, 7, 8, 9, 10, 11. I got 12 here. 9, 10, 11. 11. 5, 6, 7, 8, 9, 10, 11. I got 12 here. 10, 11, 12. 11. 6, 7, 8, 9, 10, and 11. So for this rhythm, I am regular, and I can count by tens to get my heart rate. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 110. My heart rate is 110 beats per minute. That is it for this chapter. It seems a little complicated. It's really not that bad, or it may seem easy. If it seems easy to you, then you did not do your practice problems and you do not fully understand it. Make sure you do your practice problems before you start doing your homework assignments, that you fully understand what you're doing. Give me a call, leave me a voicemail, or send me an email, and I can help you. I have tried to, I've gone over the PowerPoint with students one-on-one over the phone, and they seem to have done better. And also we can set up Zoom conferences if you need that as well. All right, good luck, and again, you've got this. Stay confident.